Okay, so today we are learning about finding things like sine, cosine, tangent, cosecant, secant, cotangent, using the unit circle. You're going to have a terminal side of some theta. Every time you have a terminal side of some theta, you are going to connect that to the x-axis. You will connect that to the x-axis. Which axis is it connected to? The x-axis. When you connect it to the x-axis, that forms 90 degrees with the x-axis. So the theta is right there by the origin. It's that angle. The 90 degrees is where we drop down to the x-axis, only the x-axis. This right here is an ordered pair, which we normally call xy, right? And to graph that ordered pair xy, you would start at the origin and you would go right, how far? X, right? And then we would go up, how far? Y, and that's where the ordered pair comes from. And then the radius, we don't know, is r. And to get the radius, we would use x squared plus y squared equals r squared, Pythagorean theorem, which is also the equation of that circle. Okay? And so if we wanted to solve for r, it's all the way down here in the third little paragraph, third sentence. I don't know. If we wanted to solve for the radius, then we would take x squared plus y squared, and then we would square root that answer. That is using the Pythagorean theorem. That's also using the equation of a circle to find the radius. One more thing from this first example. Sometimes the terminal side is somewhere other than the first quadrant. The terminal side might be in the third quadrant. And if the terminal side was in the third quadrant, I used a degree that was greater than 180 degrees to get there. But when I draw that triangle, when I draw that line to the x-axis, and I make that 90-degree angle, I have something called a reference angle. My theta is now a reference angle. I'm not going to use something greater than 180 degrees. I'm going to use something that's less than 90 degrees for theta, the reference angle. All right, so in the first quadrant, it was just the degrees that I had rotated to get to the terminal side. But like in a different quadrant, you might have to use different degrees than the original. So we'll see that happen. But that's the reference angle. Every single thing that I've gone over is reviewed from a previous course. So that's why we're going kind of fast. When you find the trigonometric ratios, we are going to use the values for x and y. The side lengths of this triangle, we're going to also use the r, and these are written for you. The sign, you need to memorize. The sign is always y on top. The sign is y on top. I remember that by just kind of imagining the word sign written with a y instead of mine. I don't know. Yes?
Wouldn't that be like the same opposite?
Oh, it's exactly the same as opposite of hypotenuse. Exactly. But what we're doing by saying y over r and x over r is we are eventually getting to something that goes faster than thinking about where's the opposite, where's the hypotenuse, where's the adjacent. We're getting to something that's going to go faster, and that's going to happen right down here too. So when you write the sign, it's always y on top of the radius. When you write the cosine, it's always x on top of the radius. And then the tangent is always y on top also. So both sine and tangent have y on top. but the tangent is y over x. You need to know these. Then cosecant and secant and cotangent, we just reciprocate the first three. Since the unit circle has a radius of 1, that's why it's called the unit circle. The radius is 1. That means up here, where I see all the r's, every single r is now 1. What would our sine of theta be in the unit circle? So y over 1 is y. So if I'm looking at this picture over here, and I know the ordered pair, I was going to make something up.
6.
2, 3. Sure. If I knew that the ordered pair was 2, 3. Nope, that's not going to work because that's not in the unit circle. How about I will use one that is for real.
Well, if the radius is 1, doesn't the y have to be smaller?
Yes, it does. That's why I said that's not going to work. So let's say that was the ordered pair. Those hopefully look a little familiar to us. So if that was the ordered pair, if we went over 1/2 and then up square root of 3 over 2, the radius would be 1 in that case. And I were to find the sine of y, I would just say, oh, that's square root of 3 over 2. It's just the y value. So you don't have to put it over r because r is 1. All right, so the cosine of theta would be x, and then the tangent of theta is still y over x. And cosecant, that's going to be 1 over y, which is the reciprocal of y. Secant would be 1 over x, and cotangent will be x over y. So I just flipped those. All right, example 1, determine the exact values of the 6 trigonometric functions of angle theta. And they've given the point. So I'm looking at this point. Which quadrant is this point located? 1, right, because they're both positive. X and y both positive. And we're going to go over 12/13 and then up 5/13. I'm not going to do this exact. I just noticed that I'm going over more than double than I'm going up, so I'm going to approximate it. I'm going to go over about here. That would be 12/13 this way. And then I'm going to go up about 5/13. Sure. All right. And then that's the ordered pair that is given to me right here. And I formed a right triangle. So I've got my 90 degrees where it dropped down to the x-axis. My theta would be over by the origin. And we have to find the 6 trigonometric functions. So we're going to find sine, cosine, tangent. And then we're going to flip them. So you're going to use your formulas from the front page, but we want to start memorizing those. So I told you sine has which one on top? Sine has y on top.
Wait, this is all saying that the radius is 1 for the example 1?
I haven't found the radius.
Do we need to?
Oh, do we need to?
Yeah.
Because for sine, it's y over r. So yeah, we do need to find it.
7.
So how am I going to find that?
Square that, square that.
The radius is equal to the square root of x squared plus y squared. That's also written on the first page. So the radius is equal to the square root of 12/13 squared. I'm not going to use my calculator, just so you know. And 5/13 squared. So when you square a fraction, you can just square the top number and the bottom number separately. So 12 over 13 squared is 144 over 169 plus 25 over 169. They have the common denominator, so it's the square root of 169 over 169, which is Okay, so this is on the unit circle. Oh, that worked. That's all right.
Great.
That's all right. So it is on the unit circle. We know that the radius is 1. So now we go through in our sign, we're going to put y. Ooh, since it is the unit circle, you don't have to do y over r. You can just do y. So 5/13. And then cosecant, flip it. 13 over 5. Cosine. Cosine is x, so 12/13. Secant, flip it. Tangent theta, that one we are going to have to put what on top? We're going to put y on top. That would be something you memorize. That tangent is always y over x. And that means I'm going to have,
So can't this be 5 over 12?
it does end up being that. How did you know that?
Because if you actually divided the 13
Right. So I'm taking 5 and divided by 13 and 12 divided by 13. That's also the same thing as 5/13 multiplied by the reciprocal of the denominator. So the 13th do cancel, it is 5/12. And the more you just practice with fractions, the more you can see that before even having to do the work.
If we did it, however, like, we had all that except we didn't put 5 over 12, would you take it off?
You mean you left it not simplified?
Yeah.
Yeah, I would.
Okay.
So you do want to reduce these and simplify. We don't leave fractions inside of fractions. Okay? See? Easy stuff, right?
Yeah, I actually like this so far. It's not too bad.
So evaluate the 6 trigonometric functions at each real number. This t, that is just saying we're finding sine of t instead of saying finding sine of theta, but it's the exact same thing. So please don't let the t throw you off. It's just they've used the t instead of theta. Now, do not convert yet. Do not convert. We need to know where pi over 6 is on the unit circle. So I'm going to find where pi is. Where is pi?
180.
Right, that's over here. So if I took this top part and I divided it into how many equal places? 1, 2, 3, 4, 5, 6. 6 equal places. This is one of them. That would be right here. Now I'm just going to pop that out and draw the triangle a little bit bigger so I can write on it. Okay, same triangle. So this would be where our theta is. Since I took pi and divided by 6, that's the same thing as taking 180 divided by 6. What angle is this one? 30 degrees. So what kind of triangle is this? 30, 60, 90. So to make 30, 60, 90, across from 30 is always 1, hypotenuse, 2, and right of 3. However, this is a unit circle, so the hypotenuse, the radius has to be 1. How can I make 2 into 1?
We have to divide everything by 2.
You need to divide everything by 2, everything, so that it is a similar triangle, but now the radius is actually 1.
Radius always have to be 1.
For the unit circle, the radius needs to be 1. Now, I will tell you, if you did not divide it and you just found your sine, cosine, and tangent off of the not divided by 2, you will still get the same answer. But for those of us that are truly trying to learn pre-calc here, we need to divide it, and this is leading us to further things, okay? But if you left them in the red numbers, you'll still get the same answers. It's going to take you longer. So we're going to do sine, cosine, tangent. Sine is always what? Y, 1/2. Cosine is x, square root of 3 over 2. Tangent, y over x. It will be 1/2 over square root of 3 over 2, which is 1 over square root of 3, which is square root of 3 over 3. 30, 60, 90 comes up all the time. So does 45, 45, 90. So the faster you memorize these answers, you don't even have to do any of this work because you know them. I already know sine of 30 is 1/2 because I memorized it. That one's easy to memorize. I know square root of 3 over 2 is the other one. So once I know where 1/2 is, I know this one. We'll talk about that later, about memorizing it. But the faster you start memorizing, the better. We also had to do the other 3, so we're going to flip all these. So cosecant 2. Secant. Good. 2 radical 3, and you can say square root 2, that's also fine. And then cotangent.
Wait, wouldn't it be
3
for the
radical 3
secant?
over 3.
Look over it.
What did you say? Oh,
Wouldn't that be over 3?
this is over 3. Yeah, you're right. I'm sorry. That was me working too fast. Hey guy, if I'm working too fast, I better slow down, right? Okay.
Your teacher.
3 radical 3 over 3.
But then the 3's cancel.
Okay.
I actually flipped this step here. I flipped that one. All right. Again, the notes will be up on Canvas if I'm going too fast. Next is when t or theta is 5 pi over 4.
So that's going to
So
pass
that's a
180.
over 180.
Right. So what you're going to start thinking about is, all right, here is pi. And we're dividing pi by 4. So I need to take this pi and divide it into 4 equal places. 1, 2, 3, 4. But there's actually 5 of them. So I'm going to go one more of those same pieces. So I divided by 4. I took pi and I divided by 4, and then I took 5 of them.
So,
Let's get a reference angle. So that's what our theta really is. It's the reference angle. If I take the top portion and I divide it by 4, or if I even look right here and I divide it by 2, what's one of those? 45 degrees. So this is a 45, 45, 90. Good.
so we always go up to the x-axis.
Always to the x-axis, yes.
So we know theta is 45.
We do know it's a 45, 45, 90. Yeah, because when I divide 180 by 4, they're each 45 degrees. Yes?
Can you label the y, x, r just on this one, just so I know I'm doing this right?
Here or here?
Up there.
Right here?
Yeah.
Are you talking about the numbers or the just letters?
Just the letters. Okay.
So we're going to plug in these numbers, and we should know our formulas for 45, 45, 90. This one is 1, this one is,
1.
and then this
Square
is,
root of 2.
okay. But for the unit circle, I need the radius to be 1.
Square it.
So if I divide by square root 2 all of these, then this one is equal to 1. And then from there, I'm going to rationalize. I'm just going to change the color so you'll have the answer in a different color. This is going to be square root of 2 over 2. And then this one will also be square root of 2 over 2. And one more thing to think about is where on the XY axis, which quadrant this is in.
3.
So this is actually going to the left and then down. So this is going to be negative and negative. I can go put those in from the originals. I didn't put them in the original. So you're going left and down. You do have to have the negatives in there. So we're going to find sine. Sine is the y. You can see where y is.
Negative square root of 2.
Negative square root of 2 over 2. By the way, as you're memorizing these, well, for 45 degrees, both cosine and sine, both x and y, they're both square root of 2 over 2. Memorize it. Radius? 1, because the unit circle. So when I have cosine and sine both square root of 2 over 2, and then I put x over y, the tangent is just 1. That'll be another thing we memorize. We get these memorized, and then you get through things a lot faster. Is it okay if I don't write the other 3? Can we just keep going? You just flip them?
Yes.
And if you need help and you want me to go over the other 3 with you, we can certainly do that and study help. All right, next is t equals 0. So I'm going to go ahead and draw where t equals 0 on the unit circle. T equals 0 right here. I don't have a triangle. Does anybody remember from last year what this was called?
Oh,
Nah. No.
I
Okay.
remember this was one of the hardest. You had to like visualize the triangle.
Nah, you don't need to do that.
Really?
Nah. What ordered pair is that?
That would be.
Okay, that's x, that's y. What's our radius? So now we do sine. Sine is y, 0. Cosine, x, 1. Tangent, y over x. Y over x. Sine over cosine, y over x. 0. Cosecant. We're going to flip 0. How do you flip 0?
0
Uh-uh.
or 1 over.
It's 1 over 0, which is undefined. I don't really have enough space here. Undefined. Cosine, that would be secant. Flip 1, it's still 1. Cotangent. Flip 0, undefined.
Why didn't I know this last time?
Oh.
Because he made us like try to think about the triangle being right in that spot.
Yeah. There isn't a triangle, so.
Well, yeah, that's what he, but that was the only way you could make us understand.
I'm sorry. All in the past now. Okay, this one, t equals pi. Do you know where t is pi? 180, so we're going to go here to here. That's another quadrantal. We're going to use our ordered pair, -1, 0. So sine of theta, sine is y, sine is y, 0.
Oh, I'm sure wrong.
Cosine is -1, tangent is 0. And we flip them. Cosecant is undefined. Secant also -1, and cotangent undefined.
I remember I just memorized all of these because I didn't know how to do it. I just memorized the answers.
Yeah, I don't think I have these memorized. I think I just use the ordered pair every time. Maybe if I practiced it more. Evaluate the 6 trig functions at t equals -pi over 3. So we're going to use radians. We're not going to convert it. We have to be thinking in radians.
So it's negative.
So I'm going negative, and the negative only tells me which direction to go around the circle. So that tells me I'm going to the bottom part, going this direction. I'm not going to the top. And it says divide it by 3. So I'm going to take this bottom, and I'm going to divide it into 3 equal places. 1, 2, 3. And then I'm only using one of them. So I'm going to take from this ordered pair, I'm going to draw straight up to the x-axis. And I'll go ahead and pop that triangle out and make it bigger. Pop that triangle out. Here's the theta right there by the origin. And so we need to figure out our x, our y, and our radius. And this is going to be a unit circle. So our radius will be 1, but before I get there, let's just figure out, like, what would this be in degree? That would be a 60 degree, right? So then across from 30
Just one.
is the 1. That means over here is square root of 3, and then the radius is 2.
We're gonna divide everything by 2 again.
We're going to divide everything by 2. And do I have any negatives there?
No,
Yes.
Which one's negative?
radical 3.
Right, because we're going down at that point.
Is
So
the
we
radius
make...
ever negative?
No, because to get r, just going back to the very first page, this is a good question. To get r, we're doing like x squared plus y squared equals r squared, so it can't be negative.
Okay.
After you square it, it's positive. All right, so we have our 3 values, and we're going to go ahead and find sine, which is y, which is negative square root of 3 over 2. Cosine is x 1/2. Tangent is y over x. And I'm just looking at my sine and my cosine right above it. I'm doing y over x. What's going to happen to that 2 and the 2? So I just get negative square root 3. The faster you can start seeing these patterns, faster you memorize them. It's going to help you. And then we flip them for the other 3. Is it okay if I move on? Okay.
So,
Yeah.
or in case we had one that was on like pi over 2, is that the same as we were doing when we were doing like 0 to pi?
That would be
Like
quadrantal, yeah.
Okay.
I think we do have one of those. We do have one of those coming up.
Oh, yeah.
Yeah. All right, next one is 13 pi over 6. So we want to kind of think about where this is going. I know you guys are taking really good notes right now. You're not missing anything.
No.
Certainly not playing on our phone. That would be embarrassing. All right, so we're going to go 13 pi over 6. You know what? I'm not going to divide this by 6s. I'm not going to divide this by 6s because there's so many of them. I'm going to think 6 goes into 13 how many times?
2.
So that would be a full 2 pi plus another leftover pi over 6. 6 goes into 13 like 2 and 1/6 times. So that would be a full 2 pi. That would be 1 full revolution plus another pi over 6. So I'm going to go all the way around once and then do another pi over 6. So I can divide the top by 6s if I still need to. But that's where I'm going to end up. I do not need the full 13 pi over 6. I only need the reference angle. I only need the reference angle, which is pi over 6, which is what degrees? 30 degrees. So once I've figured out the reference angle, then I can put all my sides in. Across from 30 is always the 1/2. Whoa, I already divided by 2. And then this one's square root of 3 over 2. And then this one is 1, because it's a unit circle. And we can fill out our sine theta, 1/2. Cosine theta, square root of 3 over 2. Tangent theta. Tangent is y over x.
Square root 3.
It'd be square root of 3 over 3.
So,
Yeah.
what's the difference from what we normally have been doing besides the fact that the rate, we have to give the radius is 1?
Okay.
Okay.
I'd say the only like super new stuff, which is not even new to this year, would be the fact that I just went around more than once
Okay.
rather than one triangle that was provided for you. I'm taking it off of going around a couple times.
Okay.
And then the quadrantal we had not done yet.
Oh, yeah.
The ones that are on. You guys can flip those on your own. This one's negative 7 pi over 2. So this one here would be a good one to pay attention to.
Is this the quadrantal?
If I take 2,
Because that's negative 2, 7.
that's like negative 3.5. So it'd be like negative 3 pi and another negative pi over 2. They're both negative.
We go around like a full time and then another half. And then,
So it's like,
Yeah, so I'm going to go, and I'm going negative, so I'm going to go this direction. This is 2 pi. Then I'm going to go 3 pi. Then I'm going to go pi over 2. Oops. So again, I'll do that again. I'm going to go negative direction all the way around. There's my 2 pi. That's 2 pi. Then I'll keep going, another 1 pi. So far we're at 3 pi. And then we go another pi over 2. And we can see that's quadrantal. What ordered pair?
0,
0, 1.
All right, so we do sine is y, which is 1. Because sine is x, tangent is undefined. And then we'll flip them, cosecant. I'm flipping this one because we haven't done this one yet. 1, secant. If I flip 0, I get undefined. And what happens if I flip tangent? That one would be 0.
So the second one, is it like this kind of this, or the next one, is it kind of the same? It's like 0, negative 1?
The next example?
Yeah.
Right.
Okay.
I'm going to skip this one just for time because we've already done one that's like this. It just, instead of going up, we go down to get to pi. That was it. These say using a calculator. We've already actually learned how to do these. There's just one thing you need to pay attention when you do it. One thing you need to pay attention. What mode is that in? So you need to make sure that your calculator, when you do this one, is in radian mode. So you will type in tangent pi over 3. Just make sure in radian mode. And it says round to 4 decimals. And then next one says cotangent. How do we type in cotangent? Oh, wait, is it radian or degree?
That's radian.
No degree symbol, so it's radian. So I'm still in radian mode because there's no degree symbol.
Cotangent is 1 divided by tangent.
1 divided by tangent 1. So that's what you would type in. 1 divided by tangent 1. Hey. Cosine 45 degrees. What mode should I be in? Change that to degree mode. And I know that you're all doing this with me just to make sure you're doing it correctly. Approximately. And then the last one, do I need degree mode or radian mode? And how do we type in secant? 1 divided by cosine, 1.8. Okay, the very last thing before we start our assignment. You see that chart?
Yeah.
I want you right now to take a moment and fill in the numbers, not like X or Y, but like fill in the numbers that you can remember without having to go draw a triangle and figure them out. Like, do you right now remember what the sine of 30 degrees is? On your own. Take a moment. We'll go over it. Take a moment on your own. Okay, so memorization. Sine of 30. 1/2, memorize that. Sine of 30 is 1/2. Sine of 30 is 1/2. Now sine of 30, yes, is the same as cosine of 60. 1/2. You gotta know sine of 30 is 1/2. I just remember like 30 is the smallest and 1/2 is the smallest. I kind of put those together in my head. Okay, that tells me now cosine, that's gonna be like the other number on top, square root of 3/2. And that's the same as sine of 60. And then from there, I can find my tangent. This one's going to have the square root of 3 on the bottom, so it ends up being square root of 3/3 when you rationalize it. And then this one has square root of 3 on top. When I memorize these, I don't know, I just think that 30 is the one that has the multiple 3s. Like, yeah, it's a 30, and then it's got a 30 and a 30, and all the 3s, and that's how I've linked those two together. All right, 45 degrees, both cosine and sine are the same. What are those?
Square root of 2 over 2.
Square root of 2/2, square root of 2/2, memorize. And then 1 for tangent. 0 degrees and 90 degrees are both quadrantal, and 0 degrees would be the ordered pair
1,
1, 0,
0.
and then 0, 1, and then we've learned today that sine is y. So sine here is 0, down here is 1. Cosine is x. And then tangent is y over x, so that one would be 0, and this one would be, oh wait, did I do that wrong? No, I did it right, okay, undo. What's wrong? Question? There are patterns in here which I will show you later, so you can help memorize it better. The assignment